Today we're exploring the area of rectangles and also squares. So we're going to first start with a little sketch on the area of a rectangle and why the formula actually works. So the area of a rectangle is just base times height. So we go to a little diagram. We have here all set up, ready to go. Each of these boxes represents one square unit. I'm going to change these dimensions a little bit to make it a little bit easier to work with. But let's say we got a 4 by 6 rectangle. So we have a height of 4 and a base of 6. What I want to do is take a look at the area of that rectangle. So essentially I'm going to take these 1-unit squares and I'm going to add up how many there are. So we've got 1, 2, 3, 4, 5, 6 in that row, 6 in the second row, so that's 12, 18, 24. Again, we can go a little bit quicker. We have smaller dimensions. 2 by 4, we have 4 and 4. Together that gives us 8. Again, a quick way to do it is just multiply those dimensions together, the base and the height, the length and the width, whatever we want to call it. It's the unique dimensions that create that rectangle. So just some basic examples here, and then we'll get into a little bit more complicated stuff. We're going to find the area and the perimeter, and to include units in our answer where it's appropriate. So number 1 is just a really basic one. I think we're going to skip that one because it's maybe a little bit too easy. But let's take a look at number 2. And number 2 is a little bit misleading because it appears that it might be a triple because I'm seeing those sides 8 and 15. I see a right triangle. So I'm thinking maybe my third side is 17, but that clearly is not true because 15 is the hypotenuse of this right triangle. So if I have an 8 here, I know I've got an 8 here on the other side. That's a property of rectangles, that the opposite sides will be congruent. To find that third side, I'm going to use the Pythagorean theorem. So I'm going to call this x. So to find x, I'm going to do 8 squared plus x squared, and that should equal 15 squared. 8 squared is 64. X squared is 15 squared is 225. And then x squared is going to give me 161. So my side of x is the square root of 161. And it seems like I should be able to simplify that, but there's really not anything that goes into that would work out really nice for us. So we're going to leave it as is. So what I'm looking at next is to take those dimensions that I have, and I'm going to try and figure out what the area is and also what the perimeter is. So I'm looking at the area. I take my 2 dimensions and I multiply them together. So my dimensions are this height of 8 and this base of the square root of 161. So my area, simply put, is just this. Again, I forgot my units, so I better put those units on there. When we're talking about area, we're talking about square units. So I had centimeters for both of those dimensions, become centimeters squared. And then the perimeter, I'm going to add up all 4 sides. We know that the opposite sides are equal or congruent, so I know that the top side is the square root of 161, as is the bottom side. My left and my right sides are both 8. So when I have the perimeter, I add up these 2 8s, I get 16. And if I add up a square root of 161 and another one, I get 2 of them. And my units for perimeter will just be centimeters. Number 4, we have what appears to be a square, and I recognize that because it's got the 4 sides equal, and I'm seeing also right angles. So it indicates to me that that's going to be a square. To find the area and the perimeter, what I'm going to have to do first is find the measurement of one of the sides. Now, if you recognize this as a 45, 45, 90, it makes things a little bit easier for us to solve. So if we use that idea of a 45-degree angle here, and a 45-degree angle here, and if we're using the ratio trick here with x, x, and x root 2, if I'm trying to find out what x is, I can use that equation, x root 2 equals 4, to find out what x is. Again, you've got many options. I think probably the easiest thing, in my book anyway, is to take this and multiply both sides by root 2. So on the right side we get 4 root 2. On the left side we get 2x. So divide by 2. And that's one of our sides, 2 squared root of 2. Okay, so area is just, because it's a square, it's side squared. So we take that 2 root 2 and we multiply it by itself, which would give us 8. And then again, we're dealing with centimeters squared. And then the perimeter, there's 4 of these sides. They're all the same. So I'm going to take 4 times 2 root 2, which gives me 8 root 2 centimeters. Let's take a look at a question like number 7. The length of a rectangle is twice the width. If the area is 72, find the dimensions of the rectangle. Actually, let's do 8. I think 8's a little bit more interesting problem. The width of the rectangle is 4 less than the length. The area is 60. Find the dimensions of the rectangle. So my first thought on this problem is let's draw a rectangle. And here they're saying the width is 4 less than the length. So the width is the length minus 4. So if I call this my width, that's length minus 4, and this is my length. The area of the rectangle is 60. So again, area is just multiplying those two dimensions together. So we're going to call it L times L minus 4, and that's got to equal 60. Now, there's a number of ways you can do this. One way is to guess and check. Just try some numbers and see if they work. But that's assuming that we're probably going to get a nice whole number for our side. It might happen, it might not. So I think probably the best option for us, the one that's going to work just about every single time, is let's go ahead and multiply that out. Let's take that L and distribute it. And I'm going to bring everything over to one side so I can factor. Okay, now that I've already done that, I've got L squared on the same side as the L, and the other number that we're dealing with, and a 0 on the right-hand side. I can apply that zero product property to factor this. So to do that, I'm going to use the area model. And so I know in that first box I'm going to have L squared, so that's got to be an L and an L. This bottom box here, I go out negative 60. So what I'm looking for are two numbers that multiply to 60. We'll have a difference of 4, and I'm thinking I'm going to have a 10 and a 6. And notice that that's a negative 4. So if I plug this in as a 6L and a 10L, to make these into a negative 4, this one has to be negative. So then my factors become L minus 10 and L plus 6, and I set those equal to 0. So the one option here is that L is 10, the other is that L is negative 6. Negative 6 doesn't make any sense as a dimension of a rectangle. We're talking about lengths of sides, so it has to be a positive number. So L equals 10 would be our length. The width is going to be 4 less than that, because again here we have width is L minus 4. So if the length is 10, then the width is 6. And we're asked to find the dimensions of the rectangle, and so that's it. Just double checking, yes, 6 is 4 less than 10, and if I multiply those together, I would get 60. We also have problems where we dealt with the coordinates. Same idea, we're dealing with the rectangles, but now in a coordinate plane. So in this case, we're generally going to have to find out what the dimensions of the rectangle are. What's the base, what's the height, length, width, whatever you want to call it, but the two basic dimensions. In a grid, it shouldn't be too difficult if there are nice horizontal and vertical segments. That should be pretty easy to find the base and the height. So on a problem like this, if I'm looking for the base, 1, 2, 3, 4, 5, 6, and my height is, let's see, 1, 2, 3, 4, easy enough. Area would just be 6 times 4, and perimeter we would add up all the sides. The diagonal distance, we can set this up as a right triangle, because again it's a rectangle. So we're going to use this as maybe d for diagonal. So d squared equals 6 squared plus 4 squared. D squared, 6 squared is 36. 4 squared is 16, so together that's 52. So d is the square root of 52, which we can simplify down to be an exact answer as 2 root 13. Turns out if we did b to d, we would have the same dimension, because in a rectangle, again, your opposite sides are equal. So if we had this diagonal, we would have a height of 4 and a base of 6. It wouldn't change anything about it. All right, so that's kind of cool that the diagonals of a rectangle are going to be congruent. This one's more of the same thing, so let's take a look at one that's kind of on a little bit of a slope here. So this looks like a rectangle that's been tilted a little bit. Now one option for us is we could potentially use some patty paper and try and straighten it out a little bit and see if it falls on the grid lines. Turns out it doesn't, because the sides are really going to be nice whole numbers for us. So my other option then, if I want to find the area of the rectangle and the perimeter of the rectangle, again I need to find the sides. We can use that method of the distance formula that we applied, where we want to find out how high did the graph go from A to B and how far over, and that'll give us one of our sides. So we have a height here of 2 and a base of 1, 2, 3, 4, 5, 6. So when I add or square those and add them up, I'm going to get the square root of 40, which I can simplify to 2 root 10. I'm going to do the same thing over here for BC, and I have a difference of 1 and 3, and so that is the square root of 10. Finding the area, it's just 2 root 10 times square root of 10, which is 20. Perimeter, we're going to take the 2 that we have here, we have another 2 root 10 here, we have another root 10 here, and we're going to add those up. So the perimeter, is 2 root 10 plus 1 root 10, that's 3, plus another 2, that's 5, plus another 1, that's 6 square root of 10. So that's the perimeter of our rectangle. Now we want to know what's the relationship between AB and DC. Now we can go ahead and calculate the slope of each. I've already kind of done that for AB. It's the change in y over change in x, so it would be a plus 2 over 6. We'll simplify it if we need to. We're not going to worry about that right now. Let's look from D to C. 1, 2, 3, 4, 5, 6. 1, 2. CD is the same thing, 2 over 6 change. So what's the relationship? Well, if those lines have the same slope, then they're parallel. Same thing with AD and BC. We can drop this guy down, move it over. See, 1, 2, 3, a drop of 3 and a movement of 1. So AD has a slope of -3. And if we look at BC, it's the same thing. We have a drop of 3 for that movement of 1. -3. So again, opposite sides here are parallel. And that is property of a rectangle. So again, we looked at how do we find the area of a rectangle and also a square and the perimeter, making sure where appropriate we include units, and also looking at rectangles in the coordinate plane.